Hello everyone, today let's solve the problem number 853 car fleet. Here, fleet is nothing but the group of cars, man. Car fleet is nothing but the group of cars that is owned by certain organization or leased by business, basically, right? So just keep this in mind. So, uh, what the question states here, we are given n cars at different positions heading towards the target. So we have number of cars at the different positions, not at the same positions. Basically, we are given number of cars at different positions. So just keep this in mind. This sentence itself is very important. We are given n cars at different positions. One may be moving forward, one may be backward, or one may be at the center, right? So we are given n cars at different positions heading towards the target. Each car is moving towards the target, basically. Each car moves at its given speed and can't pass the one ahead but can merge into a fleet if it catches up. So individual cars cannot reach the target, but it can merge into a fleet. Fleet means it can merge into a number of cars, group of cars, and then it can catch up. Then if it catches up, then it can reach the target, right? A fleet travels at a slowest car speed. They have clearly mentioned when two cars, suppose two cars group up, right? Suppose two cars are in a fleet, so then it will move at the slower speed of the car. Suppose one is having the speed 6 and one is having the speed 4. When they catch up, so they move at the speed of 4, not the 6. They move at the slowest car speed. They have mentioned in the question. This itself they have mentioned in the question. So what we need to do here, we have to return the number of such fleets that reach the destination. So this part is very important. We have to return the number of such fleets that reach the destination, right? Again, we have to return the number of such fleets that reach the destination. So number of fleets by we have to form the number of fleets, and we have to return such fleets which can reach the target, basically, or which can reach the destination, basically, right? So here in this case, let's come to the first example. Here. So here we have been given two examples. Let's do one thing. Let's discuss the approach itself directly by taking first example so that we understand this one clearly. So here in this case, before discussing approach, let me tell you, here we have target 12, nothing but this is the destination. This is the target or the destination. We have been given 12. Position we have as position of the cars here, 10, 8, 0, 5, 3. 10 at the place 10 we have one car, at the place 8 we have one car, and at the place of 0 initially scratch, at the scratch we have one car. At the 5 position 5 we have one car, and at the position 3 we have one car. Speed of the 10 is 2, speed of the 8 the car which is at the position 8 is this one 4. Same goes with 053 here. For the 053 position of the cars, the speed is 1, 1 and 3, right? So the output, so here in this case, they have given, see, the car starting at 10, the cars starting at 10, speed 2, the car starting at 10, this one and this one, right? So this one will form a fleet. So just give me a second, not the fleet, basically, yeah. The car starting at 10, speed 2, and 8, right, speed 4. These two become a fleet, meeting each other at 12. So whenever these two meets, which whose speed is lesser, actually, cars 10 speed is lesser, right? 10 is having the speed 2 and 8 is having the speed 8 here in this case, right? Each other meet at the target 12. So the fleet forms the target here. So this one meets at the speed 2, basically. They move at the speed 2 after uh, becoming a fleet, basically. After becoming a fleet, they move at the speed 2 here. Next step is the car starting from 0 does not catch up to any other car. Here 0 is at the scratch, right? So it is very slow, basically. This does not catch up to any other car, so it is fleet car by itself. So first thing that we got here is 10 comma 8. 10 comma 8 is very nearby value, so this one forms one fleet, and 0 is scratch, which is very far basically, right? So if 0 is not near to 5, 3 is near to 5, these two forms a fleet, and this single 0 forms a fleet here. This itself is individual fleet here. This one is 1, this one is 2, and this one is 3. 5 and 3 here. So the car starting at 5, speed 1, and 3, speed 3 becomes a fleet, right? So here in this case, for 0 we have 1. For the car speed, for the car position 5 and 3, they are having the speed 1 and 3. So after becoming a fleet here, this one moves at the speed 1. This one moves at the speed 1, because in the question they have given, when the form of this one fleet, then the car reaches the target with a slower car speed, right? So this one, 5 and 3, when they form a fleet, they move with the speed 1 here. 1 comma 3, this one I'm speaking of, 1 comma 3, they will move at the slower speed. This one, the car, the speed of the car 5, the car 5, which is positioned at the 5 basically, right? So I hope this part is clear. The cars at 5 speed 1 and 3 speed 3 becomes a fleet moving each other at 6. The fleet moves at speed 1 until it reaches the target. So the fleet moves at speed 1 until it reaches the target. So that's what they have given here. So here 10 comma 8 becomes one fleet, and 0 becomes one fleet, and finally this one 5 comma 3 becomes one fleet, and then finally they reach the destination or target 12. So this reaches the destination by forming the fleet, and 0, this itself forms one fleet and forms the this one reaches the destination, and this forms the fleet and reaches the destination or the target 12. So this is what the question states. Very easier to understand, right? Again, so don't get confused here. Fleet is just the number of cars or group of cars. That's it. We are grouping the group of cars accordingly with the question they have said. We are grouping the cars. It has to form this one fleet, and it will form the fleet by the nearest number that is possible. See here, 10 comma 8 is nearest number to 10 is 8 within this one, right? So it forms a fleet. 0 is at the scratch, nearest number to 0 is 5, but actually nearest number to the 5 is 3, so 0 does not form with 5. 0 itself forms one fleet, and 10 comma 8 is already in a fleet basically, right? They already have formed a fleet here. 5 comma 3 forms one fleet, and this one is left alone, and this itself forms one fleet, right? So here 10 comma 8, 0, and 5 comma 3, we got three car fleets which reach the destination 12. So I hope this part is completely clear. Totally we shouldn't return this one pairs. Instead we have to return how many number of fleets that can be formed and they reach the target or destination. So here in this case we need to return 3, 10 comma 8, 0, and 5 comma 3, right? So here in this case we need to return 3. So let me delete this one once, and let me come to the second example. Same goes with the second and third example as well. You can just check it out in the same way. You can just check it out in the same way that I said for the this one. What do we call example 1? So here let me read this one out. This one, target we have 10, position we have 3, and speed we have 3. We have only one car here, so we can form this can form only one fleet here, right? So this can form only one fleet here. So this itself will reach the destination with the speed 3, speed 3, and it reaches the target 10 at some point of time. So a number of fleets will be 1 itself. So let's come to the third example. Here we have been given target this one 100, position 0 to 4, speed 4 to 1. So first 0 and 2 we have the cars starting at the 0 and 2 becomes a fleet. These two becomes fleet. So basically these two, 0 and 2, right? 0 and 2, this becomes a fleet meeting each other at 4, basically meeting each other at 4. This one, right? Meeting each other at 4 means, so we have to go with the lower value. We have to go with the lower value. So here meeting each other at 4, the car starting at 4 travels to 5, basically. The car starting at 4 travels to 5, basically. Then the fleet 4, this itself forms this one. A fleet 4 and the car at position 5 becomes the fleet. This whole thing becomes one fleet here in this case. Don't get confused, because see, the car's 0, speed 4, and 2, speed 2 becomes a fleet meeting each other at 4. This will meet at the 4, because speed they have given is 4, right? So this will meet each other at 4. The car starting at 4, nothing but the speed 1 travels to 5, quite obviously. And then here the fleet at 4, speed 2, and the car at position 5 becomes one fleet here. So car fleet at 4, this one, and the car at the position 5, nothing but the speed 1 here in this case, meeting each other at 6, meeting each other at 6. So the fleet moves at speed 1 until it reaches the target. The fleet moves at the speed 1 until it reaches the target, right? So here in this case we need to return 1, we need to return 1, right? So here we have only one fleet here, forming only one fleet. This forms only one fleet, so we need to return 1 here in this case, right? I hope the third example is also clear. So let's do one thing, let's quickly discuss the approach followed by the complexities, and then let's write the code. So let's go with the first example. Here we have the first, what we'll do, uh, we need to pair the cars here, we need to pair the cars here. So just give me a second here. Here in this case we have 108053, 108053. First we will pair the cars in every way. So here in this case 10, 2, 8, 4, 0, 1, 5, 1, and 3, 3. So here after pairing, what shall we do? Let's sort the position in the descending order. Cars that is closer to the target comes first here in this case. That is the reason we'll be going with the sorting. So here let's this one. Initially we are pairing the cars. We are pairing the cars, right? So initially we are pairing the cars. Pairing the cars means here 10 is paired with 2 here accordingly with the speed. 8 is paired with 4. 0 is paired with 1. 5 is paired with 1. And 3 is paired with 3. So don't get confused. This is easier one. So 10, 2. Why we have got 10, 2 here? So don't think of anything else. We are just pairing 10 with 2 with the car with a particular speed. We are pairing this one, right? 10, 2, 8, 4, 1, 1, 0, 1, 5, 1, and 3, 3. So the next step is we are sorting the position and descending order. Means car closer to the target comes first. So we are doing this one first. 10, 2 comes first. Then means first value has to be this one, greater in the descending order. Means we are this one. Suppose if this is x and if this is y, we are, and this is x1 and y1, we are sorting based on the x1, this one, x and y, x1 and y1 we are considering, x and x1, we are sorting x and x1, right? So we are sorting this one and this one, so that in the descending order, so that the value with the higher value comes first, or uh, the cars closer to the target come first. So here in this case 10, then comes the 8, then comes the 5, then comes the 3, and then comes the 0. So I hope this you understood, right? So after this one we need to compute the time. After this step we need to quite obviously compute the time. For that computing time we are going with this formula, man. Just remember this one, right? We are going with the target minus position by speed for each car, by speed per each car. Target target 12 we have, and position we have, position we get here itself, position we get here, target here in the sense 12 minus 10, this one, by speed for each car. Here in this case speed is 2. Here in this case we get 2 by 2, nothing but 1, 1.0. That is how we got. So this calculation I have shown you. So others remain same. So here we are going with the target minus position by speed for each car, right? What is the target? Target for the first example we have is 12, right? So 12 we have considered here. This one is fine. So target minus position. Position for the first one is nothing but this one. Position is nothing but 10, the value 10, right? So target minus 12 minus 10 here, 10 will consider, and 2 is nothing but the speed for each car. Speed for each car means first one 10 we have considered. So speed of the 10 is 2. 2 by 2. 12 minus 10 by 2 is nothing but 1.0. Same thing you will do for the other values as well. Same thing you will do for the other position along with the speed, right? Target again you will consider second one. Let me show for the second one as well, and let me delete. Target will remain 10, and what is the this one this time? Position as 8 we are considering, 8 this one we are considering, right? Position 8 here. 12 minus 8 by this one, what do we call speed? Speed, what is the speed here? 4. This one we are considering. Second one, speed of the 8 is 4. So 12 minus 8 is nothing but 4. 4 by 4 we get here as 1. We get 1 here. We get 1. So again, that is how we got output 1 here. So same thing goes with the other 3 as well. So let me delete this one. You can just calculate. So we'll get 1 comma 0, 1 comma 0, 7 comma 0, 3 comma 0, and 12 comma 0. So here this is the calculation part. Now we'll be making use of the stack. So I forgot to tell this, that we are going with the stack approach, right? So we are going with a stack approach to solve this problem. So we are going with a stack approach to solve this problem. So now what we'll do, we have these values now. 1 comma 0, accordingly with the formula we have computed the time. We have successfully computed the time. First we have computed the time. Now we will push the value 1.0 or 1 here. First we have initially pushed 1.0 to the stack route, right? So now again we have 1.0 here. This value we have considered, again 1.0 we have, right? 1.0 again. So because it cannot catch up, right? It cannot catch up here because they are having the same time. Because they are having the same time, it cannot catch up. So we will push this one. The stack contains 1.0 and 1.0, or 1 and 1 here. So let's go with the next value, nothing but the 7 here. Let's go with the next value, nothing but the 7 here. In this case, 7 is greater than 1. At the top of the stack we have this one, 1 comma 0 here. 1 comma 0 here. This one. So at the top of the stack we have 1 comma 0 from the previous step, 1.0 from the previous step. We will check whether 7 is this one greater or lesser. 7 is greater than the 1.0. So we have got the new fleet here. In this case we have got the new fleet. So this forms one fleet. 1.0, 1.0 and 7. 1.0, 1.0 and 7.0. So now we have got value 3.0, and at the top of the stack, the last value we have 7.0. We will check whether 3 is greater than or less than 7.0. 3 is less than 7.0. So this joins the fleet. This joins the fleet. This doesn't form the new fleet. This joins the fleet, and so we will skip push. Will not push anything. Here in this case 3 is not greater than 7.0, so it doesn't form the new fleet. Instead it joins the fleet, so will not push anything here. This joins this fleet itself, right? So will not push anything here. So next we have got the value 12. We will check whether 12 at the top of the stack we still have 7. 12 is greater than or less than 7. 12 is greater than 7. So this forms the new fleet, and we will push this one to the existing stack. So this will be 1.0, 1.0, 7.0, and this one 12. 1, 1, 7, and 12. Right? 1, 1, 7, and this one 12. So basically the final stack size is 3 fleets. Basically the final stack size is 3 fleets. Means we have to return the size of the stack, right? So this one 1010 111, basically 117, 117, and this one 12. 117 and 12. So these are the 3. This one is the first one, 11. Second one which formed a fleet was 117, second fleet. And the third one here is this one, 117 and 12. So final stack size that we have here is, now we have is 3. Now we have as 3, right? So we have to return the size of the stack, which is 3, which is the output that we got here is 3, which is equivalent to the output that they have given for the first example, right? Simple to understand. So this is the approach that we'll be going with, basically, right? So this is the approach that we'll be going with. I hope this part is completely clear. Approach part is completely clear. We have discussed this one step by step, easily, right? So now we are done with the approach. So I insist you to try it out for the third example. Second example will be very easy. Basically they have given only one value. I insist you to try out with the third example. So these 3 forms a one fleet, basically. You'll if you try out the approach in the own way, I'm not telling the approach, keep the approach same and just try it out with a different value. So what you'll understand this one question better. You'll understand the question better. It will be, when you understand the question correctly, right, or the approach correctly, it will be easier for us to solve the problem. Again, I'm telling, it will be easier for us to solve the problem when we understand the question better. So it will be easier for us to solve the problem. again I'm telling, right? So just please do try it out with the other example. Means I insist you to try out with a different example with the same approach. So you'll get to know the this one. You'll understand the question better. So it will help us to write the code uh, easily, right? Code, whenever you understand the approach correctly, right, it will be very easier to write the code basically. So that is the reason. That's it. So now before writing the code, let's discuss the complexities part quickly. Right, so what will be the time complexity here? The time complexity would be because of n log n. The time complexity would be here because of n log n. So because sorting plays the dominant factor in the second step of the approach, if you remember, we went with the sorting. Basically, because we needed the position of the cars which is near to the target first at the beginning, right? So that is the reason we sorted in the descending orders, right? So first we paired the position and the speed of the car, and then we sorted in the descending order, right, in the second step. So that is the reason we sorted. So sorting plays a dominant factor here. So time complexity would be big of n log n here in this case. So what would be the space complexity here? Space complexity would be big of n. Space complexity would be big of n. The time complexity would be big of n log n because sorting plays the dominant factor, uh, or because sorting based on the position, and space complexity would be big of n because we are storing the time using the stack. So obviously we are storing the time, right? We are computing the time. If you remember the formula, nothing but target minus position by this one by speed. So that's the formula that we went with, right? So we are storing the time and we are making use of the stack. So overall, in the worst case, the space complexity would be big of n, right? So this is nothing but the space complexity, and this is nothing but the time complexity here. Time complexity would be big of n log n, and the space complexity would be big of n here, right, for the code that we'll be writing in the future. I hope the complexities part is completely clear along with the approach. Let's quickly write the code. Now we are good to write the code. Let's quickly write the code. Right. So initially we will be making use of the length of the position everywhere. So let me do one thing. Let's assign the length of the position to certain variable here. So I'll just go with int n equals, uh, let me paste position here, position dot length. This is fine. So what was the first step? We have to pair the position and speed, right? So exact same thing whatever we discussed in the approach, let's articulate the same thing in the form of code here. First step was we have to pair the position and speed, and then second step was we have to sort the position in the descending order, right? Nothing but cars that is closer to the target has to come first, right? So let's pair the position and speed, and then let's sort that one by the this one, position descending, right? So here in this case I'll just go with double. So cars, we need output in the fleet, right? So here I'll just go with double. Just go with new double. So this will be n and this will be 2. This will be n and this will be 2, right? So this will be for int I equals 0, int I equals 0, and this will be I less than n, and this will be I plus plus. So here within the for loop, what we'll do, let's go with the position. Position means here cars of I 0, this one will be position of this one I, position of I. This is fine. This is nothing but the position. Next, after the position, we have to go with the time to reach the target, right? So we need to go with the time to reach the target. So I can just write in this way, cars of I 1. We are making use of the double, right? So here this will be double, and the what was the formula that we used to calculate the time? Basically, it was target minus iterated value of the position. Each value we have considered, we have to consider, and each value we have to write on, right? Position of I, basically position of I, here in this case, divided by speed of I. I hope this part is clear. We have discussed this one multiple times, so I hope there is no ambiguity here, right? So next, after this step, what was the second step after this? We have to sort by the position descending, or we have to sort in the descending order. So I'll just go with arrays dot sort of cars, comma, uh, this one will be a comma b here in this case. So let's make use of the lambda expression here. So this will be double dot compare of b of 0 comma a of 0. I hope this part is clear, right? So we are just sorting by position descending. This is fine. So the next step here is let's make use of the stack. Let's make use of the stack here. Stack. So this would be double stack. This would be double. So here let's initialize the stack to new stack. So this one is fine. New stack. So we are just initializing the stack, or we are just creating the stack here. This is fine. We are just going with the double. As we need the solution in fleets, right? So here, and this is fine. So after this step, what we were doing, we have to traverse the sorted cars and we have to form the fleets using the stack. That's what we did in the approach. So same thing, let's articulate the same thing in the form of code here. So let's go with the iteration part here. This will be int I equals 0, I less than n, and let's increment the I here. Within the for loop, let's go with the double. So here let's go with the variable name time, and let me assign this one to the cars of I and 1. This is fine. So the next step is if the current car takes more time than the top fleet, then it cannot catch up. In third case failed, right? If you remember, third or the fourth case failed. 3.0, I think. That was basically, yeah, 3.0 was less than 3 and then 12 we got when we calculated this one time. 3 couldn't catch up with the 7, right? 3 couldn't catch up with the 7. 3 was less than 7, right? Time. If the current car takes more time than the top fleet, then it cannot catch up, right? So then it cannot catch up. So it forms a new fleet. So in the stack, 3 couldn't catch up with the 7. So what we have to do at that time, we have to form the new fleet for that. So how can we articulate the same thing in the form of code? So here it would be stack dot is empty, stack dot is empty. If stack dot is empty, we are checking whether it is empty, or time greater than stack dot peak. Time greater than stack dot peak. Then what we need to do, we have to form the new fleet, or we have to push the time. So I'll just make use of the push operation that is provided by the stack, and let's this one push the time here. So this is fine. Let's do one thing. The next step is else if it merges with the existing fleet, then we do not have to push. If it merges with the existing fleet, then we do not have to push. So here we don't have to write else, I think. So it quite obviously it automatically merges with the existing fleet. If it, I mean, yeah, if it merges with the existing fleet, then we do not have to push. So we don't have to write the else, I think here. So this is fine. If condition is enough, basically. So finally we have to return the number of fleets, nothing but the size of the stack. So this we have discussed in the approach. We have to return the number of size, I mean the size of the stack that we got for the input for the example 1 was 3. I showed you 113 formed one fleet accordingly with the time, and no, 1 1 formed one fleet, and 117 formed one fleet, and then finally 117 and 12 formed another fleet, if you remember, right? So these were the 3 fleets that we got. So we returned the stack size nothing but the 3, right, for the first example. So here we need to return the number of fleets at the end, nothing but the stack size. Here let's go with return stack dot size. Simple, very simple, right? So let me format the code once. Let me hit the run button. Missing the return statement. So here, oh yeah, this one I have to give here, right? So this is fine. Just give me a second here. Yeah. So here let me paste this one. So let me format the code once. Let me hit the run button. Just give me a second here. Let me hit the run button. So yeah, now you can clearly see the sample test cases are getting passed. So let me hit the submit button quickly. So I hope this works for all the test cases. Let's see. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case. The code works absolutely correct in this case, right? So I hope the solution part is completely clear. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.